So, how do we control the congestion? So, it's basically to prevent the congestion before it happens. Actually, I mean, after congestion, we cannot anyway like we can control. So, like if it happens, how to remove it, like or if it like before congestion itself, how we can control it. Okay. So they have divided into two types. Actually, like it's open loop, and that is a prevention basically, and closed loop. That is like once it happens, how basically we can control it. So in open loop, the retransmission policy, we have to control it. Windowing policy, windowing we discussed how basically uh, stretchers and compressors that the windowing policy, acknowledgement policy. How do we really need the acknowledgement that policy we have to certain things we can discard, but that discarding policy also we need to control. Admission policy, like whether do we need to really admit certain packet, that policy we have to control. The closed loop way, back pressure, in the sense, some buffers we can add, choke packet we can, mechanism we can follow, signaling we can do. I mean, like you can say the transmitter that like I have congestion, so you can just pause for some time. So that way you can control. That is a choking mechanism, implicit signaling or explicit signaling. So the various ways of controlling the condition. So in open loop congestion control, uh, it basically helps us to prevent congestion before it happens. So in this mechanism, basically what we do, uh, it's it can be controlled either in the source or in the destination. Okay. So first is retransmission policy. In certain cases, we may need the retransmission, but when the data is very critical. If the sender feels the sent packet is lost or corrupted, then the packet needs to be retransmitted. So, but whenever we keep on retransmitting, that I mean, more and more retransmission. So that's where to prevent this retransmission, guys, right? So we can have some policy. So it basically we have to. I mean, if I can keep retransmitting, but like till what time? So we can put some timers to control this retransmission. So basically, by this mechanism, it controls the retransmission. So that like I can stop. I mean the congestion. So in the window policy, again, the type of window at the sender may affect the condition. So basically, we have to have the proper windowing size. We saw that like between the transaction, we chose the minimum of the two as the window size. Right? So that those are all the mechanism how to control the condition. So again, acknowledgement policy is something like we can have the acknowledgement such a way that like I mean we can ignore certain acknowledgement. I mean we did not send acknowledgement for all. So we can have some policy to avoid the condition by keep acknowledging and certain things like I mean whichever like repetitive data, unnecessary data, those things I mean I cannot send the I keep sending right. I mean, certain things I can discard. So you should have a good discarding packet policy in order to uh, avoid the congestion. So whenever you admit any network, right, to connect to it, so you should have some policy. I mean, if you keep admitting various network, then what happens actually basically create lot of congestions. So, I mean, before you try to connect, I mean, in certain cases, have you seen in the internet, sometimes when you try to connect to some server, but you see that like connection denied messages. I mean, especially in whenever like you check the results, or like whenever like you try to access a server, it is like more congested. frequently see the access denied kind of message. I've seen, I have seen the, hello,
Yes, sir.
yes. So those are all actually uh, basically like the congestion control mechanism. I mean, you will be just blocking certain connection so that the congestion will not be there. In the closed loop congestion mechanism, you can see back pressure. Whenever here at the destination congestion occurs, so you will have intermediate buffers. So it keeps storing there. It keeps storing there so that it controls the flow. Okay. So finally, when the back pressure reaches the source, then he will stop sending. So that until the congestion controls, he will not transmit, retransmit. Right. So that is one kind of mechanism. And choke packet, again, like we will have various back pressure, and wherever congestion occurs, right, he will send the choke packet back to source saying that there is a congestion, stop sending. Okay.
Yes.
So we already see that like what is the during congestion, what should be the actual size of window. R window and transmission and receiver window, minimum of that should be our size of the window, right?
Yes, sir.
Congestion policy we saw. Next is actually that is about transport layer. So basically, transport layer is like the understanding of TCP/IP, right? Mostly we discuss on the TCP/IP. What are the characteristics? How we control the flow? That is the whole topics, right? In the
Yes, sir.
transmission. So it basically application layer is actually what you see, how you access the website. It's in the user level. So if I ask you, how do you access the website?
Through
Through one is link, right? Web
link.
link,
Yes. Mm.
web link, and browser, right? That is
Browser.
the
Yes,
two
sir.
things what you usually deal with, right? So I mean,
Yes, sir.
as a user, you will be knowing that it is actually the application. Apart from that,
Yes.
all the things you have seen, you mostly like not bother much about. As a programmer, you have to bother when you want to develop the browser, when you want to develop the routers, when you want to develop the servers, then you have to bother those layers what to discuss. But this is something like which you will be seeing every day, right? So
Yes.
it's like a user interface. So user interface for your email, file access, transfer, routing, www World Wide Web if you want to access, or network management, all these things. It's the responsibility of that. The main thing what you will be seeing every day is the domain name, right? So in order to manage that domain name, there are various applications. One is basically that we call it as domain name system. Okay. So that domain name
Domain
system
name
is
means
pardon
the domain name means.
your website URL.
Yes, sir.
For instance, www.facebook.com. That's the domain
Yes,
name,
sir.
right? So somebody has
Yes.
to see. We talked about like various layers, but
Mm.
have we any time like talked about like something like how to handle these character-based domain names? No, right? So we talked about IP address, IP4, IPv6. In the back end, it is actually IPv4 or IPv6 kind of concepts it will be running. But somebody has to maintain, right? When I see I want to access fb.com, facebook.com, like where that data is present, which IP address is present. So that is managed by something called domain name system,
Yes, sir.
DN. Okay.
Mm.
It's a server actually which maintains all the URLs followed by routing details or IP address, so on. So whenever actually you request for www.facebook.com, it finally translates into certain IP address and it will go to that location. Okay.
Yes.
You can see here application layer is something like you say that like user says a person at wonderful.com, right? So this SMTP client will request like wonderful.com, which is present in the DNS client, and he will say that like what is the address of say 200.200.200. So then through transport layer, he will send the data to 200.200.200.5. Got it?
Yes. Yes, sir.
SMTP is simple mail transfer protocol. So mail transfer
Protocol.
protocol, it basically tells you like where it has to go. Okay.
Yes, sir.
So to identify the entity, TCP/IP protocol uses the IP address, which uniquely identifies the connection. I mean, basically everywhere like IP address is the end, but intermediately we will use various names and all for the ease of user. Okay.
Yes, sir.
So namespace, it is something like it's to be unambiguous. The names assigned to machines must be carefully selected from the namespace with a complete control over binding between the names and IP address. In the sense, like we have to choose the unique address, right? Like, can we have like in our PC, can we have something like facebook.com? No, right? I mean, it's a unique address, correct?
Yes.
So that is we
Yes,
call
sir.
it as namespace. Okay, there are like flat name or hierarchical namespace. In the flat namespace, name is assigned to an address. Okay, so a name is a name in this space is a sequence of character without structure. The names may have like a common section they do has no meaning. So in the hierarchical name, you will have suffix and prefixes. You can see that like www dot uh, facebook.com. There is a hierarchy, right? Or facebook.org. Or you will have like
Yes.
www.karnataka.gov.nic.in. That kind of structures will be there. That we call it as a hierarchical namespace. Okay.
Yes, sir.
So to have a hierarchical namespace, a domain namespace was designed. In the sense, this is where like the DNS, the domain namespace, where it stores all the IP address corresponding to that domain name. Okay.
Yes.
You can see here in the domain namespace like ARPA, COM, EDU, ORG, AD, ZW, everything it is actually stored under the domain namespace.
Yes. Yes, sir.
So each node in the tree has a label, which is a string with the maximum 63 character. The root label is null string. DNS requires that children of the node. In the sense, I can have like nic.edu, right? So I mean, you can have like nic.edu. So gov.kar.nic.edu. So this way it happens. So in
Yes.
KR, so gov dot Kerala also you can have KL or KR dot NIC dot in. So that kind of structure it will, right? So you can see here one example there. Challenger dot ATC dot FHTA dot edu, right? So finally
Yes.
challenger dot ATH dot edu. Okay. So if a label is terminated by a null string, then it is called fully qualified domain. Okay.
Yes, sir.
If it is not terminated by null string, then it is called partially qualified. So you can see here some example. So challenger.ate.ebda.edu is fully qualified domain name of Challenger installed at Advanced Technology Center. Okay, so the DNS server can only match the fully qualified domain name address. Okay, so that is actually the name must end with null label. Okay, but
Yes, sir.
here, if a user of jhta.edu site wants to get an IP address of the Challenger computer, she can define the partial name Challenger. Okay, so here, if we just like atc.jda.edu, so it is like not complete, right? I mean, like only last few 3 lines for this. Actually, partially domain. Okay,
Yes.
you can see here you have domain and again one more domain, like finally .com. Okay, so you can see that like gov.kr.nic.com. So like this, it will be split type.
Yes.
So usually this DNS, right, it will be distributed across various computers because we assume all the website and IP address somewhere you store in the single computer. What will happen? If that PC crashes, whole world's data will be lost, right? So that's where it's distributed across various servers. So again, we saw that like hierarchy of name server properties. So you can see here fsda.edu. So bk.edu, everything is connected to edu server, in .com server, US server, India server. So finally, we will have root server. This way,
Yes,
like
sir.
DNS is distributed. Okay. This is actually zone. I mean, like whatever the splitting we did, right? That we call it as zone. So we have two servers. One is primary server, which actually contains the detail of zone. Okay, and we will have secondary servers like you might see that like GoDaddy or HostInja.com. Right, so that's where like they store the information of the zone. Whenever it updates, it has to keep on updating. So that's where we call it as a secondary server.
Yes.
You can see how this is DNS protocol. So country domains like .in, .us, .cn, you can see it. Generic domain .coms, inverse domain or like .cc, that kind of things. That all basically connected to your root domain. Okay, you
Yes,
can
sir.
see here. I mean, same thing they're explaining again and again. So arrow, biz. So this way actually you can have the domain. So this is the meaning. What is the meaning of that? ORG is non-profit organization, network support centers, name, personal names, MIL, military groups, information service providers, right? In the India, we will have something like .in, that means Indian domain, right?
Yes.
You can see AE, France, US, country domains. So you will see something like IP address domains also, that we call it inverse domains. So we will have something called resolution, in the sense whatever the DNS is there, right? So that has to be resolved into IP address. So basically, resolver will help you to find the IP address. So you can see root server. So whenever it actually like client requests something that goes to the root server, it resolves and route to particular location. That we call it as resolving. I mean, if you see here, that like from end to end, reach till here, mcgarw.com, it responds back to this client. That is actually recursive resolution. Iterative resolution. So if you can see like client and servers. So it happens across all the PCs. So it is actually kind of iterative uh, resolution. So DNS usually it will have query and response. So I mean like whenever you want to get some IP address, right, you have to query some server. So that is actually we will do query to the server. So it will say the IP address of. So the format is it will have header, which is again 12 bytes. So you can see header, quick question. So answer section, authoritative section, additional section, how it responds. So
Yes.
identification, these kind of flags actually like number of additional records, how much it is, everything it will be sent. Finally, the email. So in the email nowadays, like we can send text, audio, video, right? Several components.
Yes, sir.
So basically, it has a protocol that is SMTP protocol. I mean, you can see if you want to send some data, so it basically it goes to the system and like that is server, and it gets back to another user.
Yes,
Okay,
sir.
you can see that is a SMTP, system mail server. So he will send the data. You go to the system mail server, and through internet it will receive other end the system mail server. So he will get that. That's how the data will be sent in the. You can see here in the LAN centralized server it will go. Then it will go to again SMTP, and it will go to the through message transfer agent. It will transfer to
Yes.
another service provider, and he will be receiving that.
Yes, sir.
Yeah, same thing. So in the message also, we have this is like a few things like which you already know. We have composing message, reading the message, replying to message, forwarding the message, entering mailbox.
The
These things
mailbox.
yeah, these things again I need not explain, right?
Yes, sir.
So user agent types. Okay, you can see what is the format of the email. Like you'll have body, header, message, and envelope. Okay, I
Yes.
hope this I will not go in detail. Okay. This is about your application layer and transport layer. Okay.
Transport.
Quickly, I wanted to
Yes.
complete this so that like tomorrow and day after also you'll be attending the session, right?
Yes, sir.
Okay. We will mostly focus on problems.
Yes, sir.
Okay. Okay.
Okay.
Thanks.
Thank you. Sir, can you upload the recording, sir? Today's recording.
Yeah. Yeah. Sure. Do that.
Thank you.
Last recordings are you watching actually?
Yes, sir.
Okay. You can share to your friends also if you want. So
Yes.
if they